think we're all good, then we'll kind of go into this. You ready for it? All right. So I'll go through this presentation today. Thank you for coming out here. This is going to be over building competitive FRC robots with limited resources. It's just kind of some learnings I and my team have had over our time in FIRST and working with what we have available. We're not a team with a ton of students or a ton of funding or mentors or anything. So these are ways that we've been able to still do well in the competitions and have fun working with the resources we've had. So kind of the overall topics, I'll do a quick intro on myself, talk a little bit about simplicity, because it's really important, one of the best things you can do. What we've done with ordering COTS parts, I'll explain what that acronym is, and standardizing to make things easier on ourselves. Resources for FRC, so especially if you're new, places you can go to ask questions and find out more about things. And just some random best practices as you're going through your build season to help use. So a little about myself. My name's Andrew Milakovich. I've done FRC for 15 years now. I was I'm an alumni of Team 498, the Cobra Commanders out of Glendale here in town. So I was a student with them for 4 years. Currently, I'm the lead mentor for RoboKrew Team 2662 that's out of Tolleson, Arizona. I'm a referee and robot inspector at some of the events up at Arizona North. You'll see me there, and I usually help out some of the state championship. And I've started getting involved with volunteering at some of the FTC competitions too. My day job, I'm the instrumentation and controls manager for EPCOR. It's a water utility company here around Phoenix and in a few other states. I help do all the programming and electrical design work in that for all the systems that pump water around and move and treat wastewater and all that. So to kind of jump into our topic today, these are different things that have helped us with our competitiveness. The first one we'll talk about is simplicity. There's a quote here from Karthik Kanagasabapathy. I hope I said that right. He was a longtime mentor of Hall of Fame Team 1114 out of Canada, and they've won the World Championship once and gotten really, really close a bunch of other times. But he always tells people to always build within your team's limits. He does some big presentations around strategy and that's one of the things he emphasizes the most. Simplicity is the #1 way you can increase your competitiveness each year. Most teams fail by trying to build beyond what their capabilities are. They see the game, you get all excited about everything you can do, and you say, oh, our robot's going to shoot balls in the high goal, and it's going to climb at the end of the match, and it's going to be able to get over all the defenses and whatever else you have for the year. If you don't have very many students or you've never built a robot ever before, you're probably not going to build a robot that can do everything perfectly in the game. That's really, really hard to do, even if you do know what you're doing. So being realistic about what resources you have and what your team's abilities are and knowledge and all of that when you're designing your robot is key. A simple robot that only does maybe 1 game task or 2 game tasks but works all the time is way more effective than one that can do everything, but it sits there and doesn't move half the time. Plus, it's also a lot more fun at competition when your robot moves. If your robot breaks every match and sits there, standing behind the driver's station for 2 minutes watching it blink its little light and not move is not really that enjoyable. You've probably heard the phrase "jack of all trades, master of none." Helps apply here. Focusing on 1 or 2 tasks and making sure that you can do them as well as you can is more effective than, again, trying to do everything in the game. You have partners in the FIRST robotics competition. They are 3-on-3 matches. Your robot does not have to do everything. You can rely on your partners to do some of the game tasks and focus on what it is that you do well and design around that. Teams have made the Einstein finals at championship and won world championships while ignoring really hard parts of the game. I got a couple teams here that have done it. Like one I'll talk about, Team 610, that was pictured here. In the 2013 game, you had to shoot frisbees into goals that were up in the air. There was also this big metal pyramid in the center of the field on each side that looked like a jungle gym. And if your robot climbed up it, the higher it got, the more points you would get. Well, it was worth quite a few points, but it's really, really, really hard to make a robot that climbs this 10-foot pyramid thing sideways up it. And what they found with their team is it wasn't worth all the effort to do that. We can make ourselves really, really good at shooting frisbees and just hang off the lowest part of the pyramid, just run into it and barely get on it, and that's good enough. We don't need to climb all the way to the top for it. They actually won their first regional they were at. They were actually the #1 seed there. They were the best robot at the competition and ended up winning the world championship that year. just because their robot did one or two things and it did them really well. They didn't worry about picking up frisbees if they fell on the ground. They had to get them from a human player, and if they fell out, oh well, you go get another one. You don't waste your time with it. But because they were so good at it, they refined what they did and were one of the fastest teams in the world at scoring. The other nice thing with simplicity is you can get a lot of extra time. If your robot is simpler and doesn't have as much to do, you can finish it quicker, which means you get time to practice. If your drivers show up to their first match and have never driven their robot before, they probably push the stick forward and run it into a wall because they don't really know how to control it. It takes a little bit to get used to. You may not know which direction is forward and which direction is backward. If you have lots of time to practice with it, you're much more effective in matches. A well-built box on wheels, if you will, it's just a drivetrain. It can't do anything else. But with a good driver and that doesn't break down, can still do well in a lot of matches. You can play defense against opponents and come up with strategy with your alliance partners so that you're still being effective and contributing to the alliance. 2 years ago, our robot, we didn't make some good design choices on what we were doing with scoring, and our scorer didn't work that well. So we were pretty much a box on wheels that year. And in spite of that, because we had lots of practice time with our driver and they were able to drive well and came up with good strategies, we were still able to captain the number 6 alliance at the regional and actually make it to the semifinals, even though all we did was defense up until the very, very end. We scored less than 5 points in most of our matches, but we still contributed and played good strategy, and you can win that way. The other nice thing with more time is you have more time to test and fix things as they break. So as you drive your robot and practice with it, you find you run it into a wall and a wheel falls off, or bolts come out or whatever. You can fix those things in practice in your shop rather than at the competition when it breaks in a match and makes you lose that match at that time. All right, so to help with simplicity, what parts you choose to use and using parts that are already built in some cases you don't have to make as much of can help you out. So COTS is the first thing we'll talk about. That's commercial off the shelf is the acronym. It's basically parts you can buy already that you don't have to make. So we talking a little bit before about Andy, Mark, and Vex. You can buy gearboxes from them that are already built. You don't have to machine them yourself, which if you don't have a mill or a lathe, or you don't have anyone on your team who knows how to machine, you probably can't build those on your own anyway. So it's useful to be able to buy it instead. It helps if you don't know how to make the parts or can't do it, you can compensate and instead be able to use something that previously, if you wouldn't have had those, if you wouldn't have been able to buy it online, you wouldn't have access to it. This is a picture of an old robot from, I'm trying to remember what year it was, 2000, something around then. You can see it looks a little more interesting than some of the robots now. There's a lot more bare metal on it and a lot of wires hanging all over the place. The gearboxes are not as clean as you might see in some of the current ones. In old FRC pictures, or in old FRC competitions, you couldn't buy very many parts and you had to make everything from scratch. And it made things harder because you spent more time just on getting your robot to drive, not on really refining how well an arm works and all of those type of things. The biggest thing, COTS just lets you focus on design and strategy. You don't have to worry much about how good am I at fabrication. It helps take some of that element out, especially if you're a team that's weaker mechanically. Like we have very few mechanical engineers on our team. Most of us are electrical engineers or programmers. So we do much better buying things and figuring out just how to get it together because machining is not our strength. All right, then standardizing parts, when you look at COTS parts or any of them, also helps with your design and making it simpler. If you limit yourself to only a few sizes or common types of parts and always try to use them, you get more familiar with them. You also have more of them available. Like if you use the same 3 or 4, if you use one type of gearbox and use it in 4 places on your robot, you only need 1 spare, because if any of them break, you can use that 1 spare to fix any of them. Whereas if you use this gearbox here and this one here and this one here, and they're all different from each other, then you've got to have a spare for each one, or if they break in a match, then you get to scratch your head and go, how am I going to fix this or make something else fit in it at that time? If you end up picking something that other teams use a lot, they're also more likely to have spares. So if you didn't have one, they might be able to lend you one. And because you have common spares or you have common tools, you don't have to store as many things. So if you work out of, let's say, a closet, you don't have like a nice build space to work out of, you don't need as much room to keep things around, which is nice. Some of the things that we'll pick might be a little overbuilt. It's more than you really need for the application, but the advantage is you have some extra safety margin with it. So like with chain, if we use a bigger chain than we need, might be a little heavier, but it's way, way less likely to break. So if you are not used to doing the calculations for how much stress you're going to put on it, or you're just not that confident in it, well, I'm never going to break that chain because of how strong it is compared to using a smaller one that you've got to think a little more about the design on it. Going into that, it's usually not the optimal solution when we're standardizing in some things. To talk about chain, 35 chain is heavier than 25, but it breaks at 3 times the strength that 25 does. So it's a lot more forgiving, but you add an extra pound or a couple pounds to your robot for using it. When you're using COTS gearboxes, you're limited to whatever gears you can buy from who you're getting it from. So you can't make the exact ratio you need if there's, oh, I wanted to go exactly 10 feet per second, and all I can get is 9 or 11 because of the gears. Well, you've got to pick the one that's closest and kind of live with it. We're really choosing overall here that easier storage, easier maintenance, and easier design is worth those trade-offs of not having the perfect solution for everything. So the rest of these slides are all just talking about different standards and that we've used. The first big one is the AndyMark AM14U3 chassis, also known as the chassis that comes in the kit of parts each year. We'll see if they keep the same number this year. Every once in a while they make a new version and the number goes up by 1, but it's been around for a while now. You can modify the gear ratios and wheels for it if you want. So they give you the basic kit, but you can make some modifications. Like we've usually used smaller wheels or bigger wheels than what has come to get over bumps or to bring ourselves lower to the ground than what's come in the kit. We usually make it a little faster than what's in there. You can put traction wheels on it too if you need to. Teams have adapted it. I know we have a demo bot that we use in parades for this that we put pneumatic tires on so that we can drive it on asphalt outside because the normal first wheels get torn up if you try to drive them outside. For most robots, moving's the most important thing. If you don't move in a match, you probably aren't going to score. It's not very fun. So if you have not built a custom chassis before and don't really have a ton of knowledge about it, it's way easier to just use this and focus on building good mechanisms on top of it than trying to come up with something on scratch for the first time and potentially have your robot not move because the drivetrain doesn't work. On the kit of parts chassis each year, they use AndyMark tough boxes for gearboxes, which means if you're a team that's been around for a while or as you do this competition for a few years, you get 2 of them every year in the kit of parts that come with that chassis. So we've kind of standardized on using them for a lot of our mechanisms. They've been around since 2008. We're an older team, so you can imagine how many of these we have sitting around over the years from all those kits we've gotten. You can take the gearbox off of the chassis plate and you can buy just the plate part that you see on the front there off AndyMark and then reuse it on a new robot. So rather than having to buy a whole new $100 gearbox, I just take it off an old one, buy a plate for 10 bucks and mount it on a new one without having to get a full gearbox for it. You want to reassemble it each year. You want to re-grease the gears to make sure they're good and make sure the gears aren't broken. Plus the rules each year, you can't just take whole parts that are finished off an old robot and put it on it. You do have to take a gearbox apart and reassemble it because it has to be built for that year. So you want to do that anyway. Again, there's a range of options for it. You can get different shafts, longer ones, shorter ones, different output types, and you can change the gear ratios with for what kind of speeds you want on it. So there's, I think, 4 or 5 speed options that you can get for the output on this now, so you can tailor it to what speeds you need for your mechanism. The other gearbox that we use for everything is from Vex Robotics, the Versa Planetary. So it's a little bit more compact planetary gearbox. We like it because of the motor compatibility it has. It works with almost all of the good motors that you can get. It has adapters that actually come with it so that you can use it for whichever one you want at the time. Bunch of gear ratios. Again, you actually pick little slices of gears and you can stack them. So you can make a gearbox with 1 gear slice and it's a 3-to-1. but then I could put a 3-to-1 and another 3-to-1. Now it's a 9-to-1. I could add another 3-to-1. Now it's a 27-to-1. So you can get just gear slice kits, and depending on the game, if you need something fast, you can use just one. The next year, oh, you need something that's big for climbing a rope or whatever. Well, now I drop in a couple more of them, and now I have 100-to-1. So it lets you reuse the gearbox year to year and adjust it pretty easily. We've built up an inventory over time. So we bought like 1 or 2 gearboxes a year and just 1 or 2 slices, but we do that each year. The old ones are still good as long as they didn't explode and you take care of them. So now we've got 5 or 6 gearboxes we can use and a whole range of gear ratios that makes it easier for us to design with. For output shafts on gearboxes, we've tended to stick with 2 sizes. One's 1/2-inch hex shafts. Normal gearboxes use what's called a key. They have a round shaft and a little metal piece that transfers the power from the shaft to whatever it's turning. Bad thing with it is if the key falls out, you cry and it spins in circles inside of whatever it is. So your wheel sits there and the shaft just goes round and round and you don't move. Hex shafts, the shape of them is what transmits the torque. So the hex can't fall out of a hex shaft like a key can out of a normal one. If your hex breaks, then you have whole other problems, but it makes it easier to work with on your drivetrains and driving your different mechanisms. Been used in the kit of part for a long time, so if you have old robots that you can take parts off of, you probably already have some 1/2-inch hex shafts. And Vex and AndyMark make it on pretty much all their standard gearboxes that you can get parts from. The other nice thing, if you're trying to prototype stuff, you can take a 1/2-inch driver, put it in a drill, put it to the shaft and run it. So you can use drills to actually test things and prototype. Or you can use wrenches on your robot, a 1/2-inch wrench. If something's jammed and you need to unjam it, you can fit it over the shaft and drive it with it. Some teams, we've done this too, you actually use the ratcheting part of a ratcheting wrench over a 1/2-inch shaft and build the wrench into your robot and use it to prevent the shaft from turning one direction. So that works good on winch mechanisms. You don't have to build your own winch, you just buy one for $10 and hook it up. The other shaft size is 8mm shaft with a 2mm key. That's the standard shaft on the sim motors, which is the oldest motor, FRC. It's been around for like 15 years now, and they include it in the kit every year, and what's normally on the drivetrain. So you end up with a bunch of them. It's nice to, a lot of the gearboxes can actually have it as an option for their output too, which can let you take one gearbox and feed another gearbox with it. Kind of as an example for that, in 2017, you had the Steamworks game where you were trying to score gears or wiffle balls and fuel into goals, and you also tried to climb a rope at the end of the match. Well, we said climbing is going to be too difficult. We don't want to attempt it during our build season. And then we saw during the first regionals that if you don't climb, your robot's not any good. You really needed to climb that year to be competitive. So we decided we needed to build a climber that we could bring with the competition and put on there. You're allowed to bring, I think it's 30 pounds now, yeah, of parts with that are already assembled to competition to put on your robot there when you get there. So what we did was we used that withholding allowance to build a climber using all COTS parts. So we built a sim motor onto one of those versaplanetary gearboxes and then used a sim output on that to feed it into an AndyMark tough box that had the longer output shaft, and we put little Velcro on it and that was our winch mechanism to try to climb up a rope with. So we were able to build the entire thing in one day because it was all COTS parts that were bought. You just had to assemble it really quick, and then we were able to bring it with, and at competition, it was just a matter of figuring out how to mount it on the robot so that it would work. Some of the other parts we use, Vex Robotics sells a system called VersaFrame. It's tubes that have a bunch of pre-drilled holes in it. They make connecting things up really nice. It's kind of like a massive erector set. You know what those are. I don't know if they still make those anymore. But it has plates that you can buy already that have holes for bearings, because if you don't have machining tools, making holes that fit bearings and they don't slip out of can sometimes be a challenge. It's also got gussets for mounting different motors onto it. We like, one of the things they sell is a linear motion kit, so it's a couple plates that you can put screws and bearings on and use it to make elevators or arm extensions, things like that. It's lighter than most extrusion. If you hear of stuff called 80-20 or that, it has bolts in it where you can slide it along any part of it and tighten it. It works well, but it's really, really heavy, And you also have these things called T-nuts that have to fit in the slots in it. And if they fall out, then you cry and have to go feed new ones in and fit it back in, and it can be a bit annoying. With this, it's easy enough to just rivet things together or bolt them in and remove them or drill them out really quickly when you need to. The frame itself can be a little expensive, so if it's too much, you can get just the gussets, and you can get normal aluminum tubing from another manufacturer, just a local vendor, and print out the paper layout of where the holes should be, and you can drill the holes yourselves. It takes more time, but it's cheaper if you don't want to spend the money on all of that. Bolts. So if you've depending on what you've had for your team, you might have a box that has a bunch of screws and bolts that you have no idea what size they are, and you hope you never have to dig through it for the right one. We've tried to, we have one of those, we just try to ignore it now and never use it. But we've tried to standardize on 3 bolt sizes for everything so that we don't have to store as many different bolt types. We use number 8 bolts. That's common for all the Vex Versa frame stuff. It already fits the holes that come with it and helps to mount some of their equipment or assemble some of their gearboxes. You can use rivets also to replace those. Then we've used number 10 bolts, which is what the size is on the chassis that comes in the kit of parts each year, and a lot of the Andy Mark stuff. Mounting Vex gearboxes usually with number 10 as well. And then 1/4-inch bolts on occasion. Those are bigger than you need typically for most stuff in FRC, but every once in a while, if you have something that's a high load application, like the bolts for the linear slides from Vex are 1/4-inch because they take a lot of load on one little point that it bearings on, and you don't want your bolt to break in half. By standardizing on all those, we've been able to kind of simplify how we handle our tools. So rather than needing to buy, you go out to Home Depot and get the big combo wrench set that has 20 wrenches, and you really only use a couple of them, and you have to dig through this pile of wrenches to find the right one you want each time. We keep bags with just the sizes we need to work with, and that's usually all we bring to most events or anything with us. We might have a handful of other ones that are off to the side just in case, but these are really what we need. So we color code our tools. We do gray for number 8, red for number 10, and black for 1/4-inch bolts. We actually mark the tools with electrical tape or duct tape because you can get them in the kit pretty easily each year. That's why we picked the colors. It's what we already had. And then we got bags to match them. So red tools go in the red bag, black in the black, gray in the gray. And we keep everything we need for each size in it. So if you need to disassemble something on the kit of parts chassis, you grab the red bag and you can get a wrench out and a socket driver or an Allen key. If I need to drill a hole for a number 8 bolt, I can grab the gray bag, and all my drill bits for that we use are already in that bag. So it makes it really nice to be able to work with different systems. We've kind of stuck to 35 roller chain for most of our power transmission that's not in gearboxes. That's just because with the size it is, it's pretty hard to break it in FRC. Usually you end up bending shafts and ripping things out of aluminum before it fails, is what we've tended to have. 25 you'll see on a lot of robots as well. It's quite a bit lighter, but you also have to think more about the design on it. I've definitely seen us break 25 chain in half on teams I've been with. I've yet to see us be able to break 35. Belts come in the kit each year. We do use them on the kit of parts chassis. For other stuff, we've usually just used chain because it's been a little more forgiving for us on misalignment. Belts, you do have to have tension properly or they jump. Chain does too, but chain jumps a little later than belts seem to when we worked on it. If you've been around a while, the current kit of parts always has belts in it, but older teams might actually have some 35 chain around. It used to be the standard chain on the drivetrain up until about 2014. Got a question?
Yeah. Do you have to buy chain or does it?
Now, the kit of parts usually does not come with chain anymore. It comes with belts for the drivetrain, and they usually don't give you anything else. So you can get Andy Mark and Vex, and some of those guys sell chain. You can also get it from a lot of the industrial companies as well, McMaster or Granger or that. No, it's all right.
For the drivetrain, the belts last long enough?
No, they work perfectly fine for it. The main reason we don't use it on arms or other things is that we're not very good mechanically. So with belts, you need to make sure they're separated the right distance and you have the correct spacing. and you need to make sure you have proper tensioning on them. Otherwise, what you end up happening is you put load on your arm, you try to lift it up, and the belt just skips and your arm falls back down. If your chain is too sloppy, eventually that happens with your chain as well. But we found we're able to more easily tension chain, or you can put half links in chain. I know a lot of people hate them, but they work if you're not putting a lot of stress on it. You can adjust the size of the chain more easily. I can put it in place and then wrap around the chain and make it on the spot. Belts, you have to order the belts in exact length. And if it's wrong, you have to order new belts. You can't make a belt, right? You can't open it up and make a new one. So.
Yeah, on the belt, talking about idler arms are pressure on there, so you don't have the problem.
Okay.
So if you have belts, then you have to talk about idler arms. It's a little round ball on a bar with a string tension on it, so you make your belt a little bit longer than it needs to be. Then this ball comes up on this arm with string and tension on it, so you don't have that overlap.
Yep. And I've seen them on machines, but yes. But again, I'm not the greatest mechanical guy, so I can't build one very well, or at least not implement it too well. Talking about motors, we've kind of stuck with 3 main motors: sim motors and the mini sim, because it's the same thing, it's just smaller. Bag motors, which is the one in the upper right there, looks exactly like a sim motor except it's smaller. And then the 775 Pro motor, which is on the upper left there. Those are really the most powerful motors you have available in FRC. The sims and the bag motors are really nice in that they have really good thermal mass. They've got nice aluminum casings. They're fairly hefty for what they are. So if you run into something and stall them and keep applying power, they'll heat up, but they'll take the abuse from it. It takes a long time of applying full power to them before they burn up and stop working. The 775 Pro motor gives you a lot of power in a really lightweight package. It has as much power as the sim, and it weighs 1/3 of what it does. But if you stall it for too long, it releases the magic smoke, and once you release magic smoke from electronics, they never work again. So when you use those, they're good for usually lower torque applications, like something where you're shooting a ball or that's not as likely to jam. You can use them on other stuff. We did use them to drive our arm last year. You just have to be more careful with design, where like when we designed our arm, we geared it such that we never ran the motor more than half power. Well, at half power, it's pretty unlikely to burn out. Whereas if we had designed it where we had to run it at full power, you jam it for 2 seconds, the motor's toast. So you have to watch what you're doing with it. You have a question?
Yeah. So, what do you have to install?
So stalling just means I'm applying power to the motor and the motor shaft's no longer turning. So if I had an arm, the arm comes down and hits that. If I keep driving into the table, my arm's not moving, but I'm applying power. Well, that power goes somewhere and it's heat in the motor. So it's usually just when you're the higher torque applications or things where you tend to stall more, things like arms where you might run into something. It can be your drivetrain too, depending on what wheels you have. Your wheels slip really easily on the carpet, you're okay, but if they dig in and don't slip, then you're applying a bunch of power and you're stalling your wheels out when you're like pushing into a wall or trying to push another robot, for example. That's why you usually see sim motors or those bigger ones on drivetrains, because you got to be really careful about using these small ones on it to avoid burning them up. All right, so then to kind of go into resources that are available, I'll talk about some different places that you can get help for FRC. So one of them's the FRC blog. It's written by Frank from FRC. He releases information about FRC. It's really active during the season, so he'll tell you about rule changes that have come up, things you should know about, scholarship opportunities, lets you know, like you look right now, there's a bunch of stuff getting excited for kickoff and making sure people know that they can download game manuals and that. He sometimes has funny jokes on there too. Not all the time, but occasionally. The FRC control system screen steps from WPI, so that's Worcester Polytechnic Institute. The picture of it on the right here. They have guides on how to wire up your robot. They have a whole step-by-step thing on how to connect electronics up, how to go through all of that, how how to program. They have example code that you can use for stuff. They have descriptions of how some of the programming works and some basic things on like how to use encoders, how to use gyros and different sensors for your robot. And they've got pictures with it, which is really, really nice. So like this one here, if you're having an issue with your radio, they've got the diagram of here are all of the light codes for your radio. So if your radio has a blinking red light, you can look on this and know, oh, it's aired or whatever it is on it. So it's they have good references when you're trying to troubleshoot why something isn't working with your electronics or your code. Yeah. I'll have some links at the end for everything, so that we go through. So FRC has their own event pages and results. That has the official competition results from the regionals and all the events going on. You can find what teams are registered at your event if you want to know who's coming beforehand, especially in later events. You could try to look up, you know, a team is coming to yours that has already competed. You could see, well, how did they do at the previous one and kind of see what was up there. Teams can obviously change their robot, but you can do a little looking to see what they had initially. It tells you where it's at, the dates. Some events have websites, and they'll link to it on there. And then afterwards, if you want to know who won awards or how you did in your matches, you can go there. The Blue Alliance is very similar. It's an unofficial event and team data host. It was around before FRC actually made their own page for it. It pulls all the official data from FIRST, but then it adds extra stuff. It'll go pull pictures from Twitter or Instagram or Chief Delphi or other places of robots when it can find them. So it'll link, oh, here's a picture of this team's robot. So you can see it on a page there. They link to match videos that they can find on YouTube or Twitch. So if you wanted to go watch match videos from your competition afterwards, Blue Alliance is a great place to go do it. And you can find most everything from the last 10 years or so is up there. Once you get beyond that, it starts to get really sketchy if they had any. And then during the season, they'll actually host some of the live streams. Twitch has started to do more of it, but they have a nice thing. If you want to watch 8 regionals at once, they have a layout you can bring up there and put them all on at once on a giant TV. Some different places for discussion. Chief Delphi is a set of unofficial FRC forums that's been around forever. It was started by a team called Chief Delphi. They don't exist anymore, but they were one of the Hall of Fame teams. They've merged into another high school and have changed names since then. They have a great resource, or they're a great resource for questions you've got on things and you want to just talk about FIRST on there. People discuss strategy. If you want to talk about strategy things for events, you can ask about fundraising, how to run your team, technical questions on how I do something with the program, how did the team do this, anything you want to ask on there. There's also the FRC Discord, which if you're older, you may not know what that is, but most of you are probably familiar with Discord in here. So there is a Discord just for FRC. It's more of a chat room rather than a forum that's dedicated to FRC. It's better suited for quick questions where you need something right away, or if you want to just discuss ideas with someone in real time. Chief Delphi is a forum, you can post on it and come check the next day and see it. Discord, if you try to come back the next day, you might be scrolling through pages of stuff to try to see what someone said afterwards. So it works good for more immediate response. Chief Delphi tends to have some more veteran mentors out there. A lot of the older guys use it. Discord is more students and recent alumni because the Discord's, I think, only been around for about 2 years now for the FRC one. It's a good place to still chat on stuff, but know you might get different audiences for what you're looking for. Vex Robotics does some DC motor testing, so you can go on their site and they actually have published data on all of the main motors for FRC, how much power it draws, how much power it can output. They have curves to show you at different speeds, this is how much power it's drawing and how much torque you're getting out of it. And you can see a lot of info about them. If it hasn't been tested by them, it probably isn't worth using. There are a handful of motors, like I don't think they've tested the current window motors, or the throttle motors, which you'll get in the kit, but they're really, really, really weak. You can grab them with your hand and stop them from spinning type of thing. So they don't have as much application, so they haven't done as much with it. There's also the JVN, which is John V. Noon. He's a mentor for Team 148. He has a mechanical design calculator. It's a big spreadsheet that you can use to help you design drivetrains, design arms, design shooters, different mechanisms using gearboxes. So is an example of it here, but you can actually put in, this is the motor I want to use. This is the gearbox I'm going to run it through and what reduction I'm going to have on it. Like this one's a drivetrain calculator. So it says I'm going to use 4 motors, 2 in each gearbox, a gearbox on each side of the robot. This is how much the robot weighs, how much weight's on the wheels. Like if you use casters, not all the weight is on the wheels that you're driving. You can enter coefficient of friction for how grippy your wheels are, and it'll tell you with your gearboxes you have, this is how fast your robot's going to go. When it's not driving anything, this is how fast it'll probably go driving around. And this is the amount of current that it draws when you're trying to push against someone max before your wheels start slipping. So you can use that to see if, like for the current there, it said it's going to be 40 amps per motor, which your motors can draw a max of 40 amps with the circuit breakers are on. If you exceed that for a long time, you pop your circuit breakers and stop moving. So it helps you design to make sure you're able to draw the power you need, and you can also see how fast things move. So they've got arm versions too that'll tell you how fast your arm's going to move. They've got ones for shooters for how fast you'll shoot balls out, all sorts of fun in that. A couple collections of just big links and resources. Team 4468 came up with the FRC Survival Guide. It's just a big PDF full of a bunch of links to different resources that are out there. The nice thing with it is that they've kind of highlighted ones that are good to use if you're newer or kind of like best uses that more teams will find valuable, editors' picks. So it's really nice to look at if you're newer to FRC and don't want to get overwhelmed by everything that might be out there that you can learn. Been doing this 15 years, you can get really, really far into it. Another good one, Spectrum, Team 3847 has a sheet they've come up with to help with robot design, and also a big presentation they have about design concepts. They have links to tons of resources. They have like the John JVN calculator. They have that and a million other calculators embedded. It can help you with anything you want to know, how to calculate distance for where to mount things if you wanted a chain run of this many lengths or a belt of this length, and just all sorts of stuff in it. Their presentation goes over a lot of stuff on how to build and design effectively. It's almost an engineering course kind of wrapped into one presentation. It's like 300 slides long. The big thing with it, it's very, very big. The sheet has tons of pages in it. The slideshow is very, very long. So if you're trying to find something very specific or you're newer to all of it, it can be a bit overwhelming to page through. I only go to it when I know specific things I'm trying to find, because paging through the whole thing, I usually don't have time to sit down and read everything in it. There's a site called the Compass Alliance that got made a couple years ago. It's a collection of teams that have worked together to try to combine some of the resources that were out there for FRC for teams and make it easier to find. It includes videos and how-to guides on how you might want to design a robot, how to plan your strategy session, how to run your team effectively, how to help with fundraising, all sorts of different topics on it. It's got contact pages on how you can connect with local teams. Some teams are set up and they're saying, yes, we're definitely willing to help people out around here if we can, or hey, we've got a field that people can practice on, and you can look in there to see what resources are around from some of those teams. They also have something they do called the call center. During build season, it's an online chat that they try to have someone manning 24 hours a day. If you've got any type of question with your robot design or something for your team, you can go in there and ask it, and they can try to help you with it. Again, it's a lot of teams that are former Hall of Fame teams, Chairman's Award winners, regional winners, and that. So it's teams who have good resources that you can tap into, and they know what they're doing. All right, just some other best practices that didn't kind of fit into the rest of this, a few parting things. At competition, I talked a lot about building a simple robot's, very helpful, especially if you can't do a ton, but scouting and strategy are the other big things that can help with your competition success. Average robot is really hard to beat if you scout well with it and do good strategy with your partners, and if you're a really good robot already, and then you scout well, pick good partners for the playoffs, and have effective strategy in your matches, you're going to win almost everything at the event. When you're talking strategy with partners, you want to be honest about your robot's capabilities. There's always some discussion before matches of, okay, what are each of us going to do here? Like if there's one goal to score in, all 3 robots can't score in it at the same time. It may not even be possible or reasonable to try to have all 3 robots scoring in it. So what do the other ones do? You want to be honest about what you can do. If your robot only scores in a low goal and isn't very good at scoring in a high goal, don't agree to a strategy where you say, oh yeah, we need you to score in the high goal. You're not going to do it very well. Your partners are not going to be happy afterwards, and your alliance is probably going to lose the match. If you play to each of your strengths, you're more likely to come out on top. Even if it may not be what you wanted to do to begin with, you find out, well, nobody on the alliance can score in the high goal. Oh well, you've got to play to what you're able to do because you're not very good at that. If we stuff enough in the low goal and play good defense, we may be able to beat a team who can score really effectively in the higher scoring methods. For scouting, if you don't have anyone really doing scouting or need help with it, feel free to ask other teams with it. It helps for preparing for matches, but even more for playoffs. It helps you with being able to pick alliance partners. The event rankings are not perfect. You don't want to end up as an alliance captain and pick just the next team on the ranking that's available, because robots that aren't very good can still end up high in the rankings, which also means even if you think your robot's not very good, you can still end up high in the rankings. So you want to scout. That way you're ready for it if you do end up being an alliance captain. Programming. If you have no preference on programming, you don't already know any of the languages, and you're just starting out, I'd say use Java. The reason being, most of the teams use Java. In 2017, 56% of the teams in FRC use Java. That means LabVIEW and C++ and the other weird ones like Python that are out there was split among all the other less than 50% of teams. So if you use Java and then you have an issue at competition and need help from someone, you're more likely to get it. Like our team uses Java for programming, and I know we try to help people out when we can. I do programming for a job, but when someone comes with a question to me about LabVIEW, I go look at their screen and go, and I'm not very helpful at it because I don't know it very well. There's also more examples, like when you look at the WPI website, most of their stuff is written for Java. So the code that you can copy and paste and just use as a starting point is usually written in Java. For your radio, last year in the kit, they included a power over Ethernet cable from Rev Robotics. I'm hoping they do it again this year. Please use that on your radio. One of the most common reasons for robots dying on the field is your radio power going out temporarily. They have the little barrel connector in it that plugs in, and nothing really holds it in well. If that, you can try to tape it, or some teams will 3D print holders to try to help keep it in, but if that comes loose for some reason, you're dead for 45 seconds. That's a long time in a match, and if you're only doing one event, you get 10 matches a year and you paid $5,000 to do it, that's a couple $100 a time you're wasting just sitting there because your radio reset. Power over Ethernet gives power through the actual Ethernet cable that plugs into it. So it's a secondary power source that'll help try to limit any resets of the radio. You're much less likely to lose that connection because it actually has a little tab that helps hold it in. And if it pops out, you can't talk to your robot anyway, so you're already in trouble. Last things were just about materials. Pneumatics can seem a bit daunting if you're already having to learn everything about FRC to begin with, but definitely consider it. You can get a lot of the pneumatic parts in the first choice kits each year, and I think if you're a rookie team, they actually give you a lot of the parts that first year as well. There's not as much in the veteran kit. But you can get cylinders and tubing and compressors and a lot of the parts already without having to spend a lot on it, which is nice. And pneumatics are very easy to do things like linear motion and holding forces. If I wanted a arm that is really basic and just needs 2 positions, up and down, if I have to do it with a motor and a gearbox and that, I've got to hook it up, I've got to drive it between the 2 of them, or I've got to put sensors on it or some kind of stop so that I can hit it where I want to be in my 2 positions. And if I don't have those, my driver has to take time lining it up. If I use pneumatics on it to just push it to where I need it to be, I can have the pneumatic down, fire it, and the pneumatic goes up and back again. Makes the design a lot simpler on it. It's good for claws as well, things you just need to open and close, and they can continue to apply force. With a motor, if I have to keep driving it, I'm applying power to it, I'm at stall like I talked about before, and if it's not designed well, you could potentially burn it up. Pneumatics don't care. They'll hold it, and they'll hold it until you run out of air and the robot's dead. FRC has a really good manual on how to use pneumatics as well. again, steps you through how to connect everything and the different parts you need for it. You have a question on that?
Yeah, so it's kind of like a piston, how like it goes down.
Yep. Yeah, so pneumatic cylinders or pistons are what you're driving through with everything on there. Other one would be, don't be afraid of wood. Not what most people would think of for robots. Usually you think of big metal creations, but wood is cheap, usually pretty easy to get at local hardware stores or just anywhere around, and you can work with it a little easier than metal. If you wood's easier to cut through, and if you don't have nice machining tools, you might be able to do some more interesting shapes with it than you could with metal pieces that you have to try to fabricate. Wood and electronics does not automatically mean your robot's going to catch on fire. There have been some teams, actually like the Bit Buckets out of Tucson here in Arizona, that have built very, very effective robots using all wood for their systems. All right, so an appendix here that, again, if you had your email over here, I'll email these slides out to you after, but this has links to a lot of the resources I talked about and other things on here. And that was everything in my presentation I had to go through today, so thank you. I wanted to see if you guys had other questions about what I went over here or topics I didn't cover. Yeah, just in the back there. And I know I'll share it with the Randy, the guy who's organizing all the workshops too, but I want to make sure these get to you guys because I don't know when that list gets sent out to all the teams. So. All right. Well, cool. If there's no other questions on stuff, thank you guys, and feel free to hang around and chat after if you want to, or otherwise, hope this was helpful for you, and good luck tomorrow. I'll see you all at kickoff, and we'll not get any sleep for the next 6 weeks.